Good morning, children. I welcome you all for today's class. Today's Bible verse will be You are the light of the world, a city on top of a hill can't be hidden. Matthew 5:14. As it is said in Matthew 5:14, we are to be people who radiate the light of God's love and truth into the lives of those with whom we come in contact, even though our message will be rejected by many, and in this world we will have tribulation. So, today's Bible verse will be You are the light of the world, and a city on top of a hill can't be hidden. Matthew 5:14. Children, today we are going to continue the same lesson, production analysis, and the topic will be isoquants. So let us learn the meaning of isoquants. The two words iso and quant are derived from the Greek language meaning equal and quantity. So the isoquant curve can be defined as the locus of points representing the various combination of two inputs, capital and labor, but yielding the same output. Even though we use the two inputs, capital and labor, but the output will be the same, and that is known as isoquants. So that is why this isoquant is also called as equal product curve or product indifference curve. Children, let us learn the definition of isoquants. As I said already, we are going to use only the two inputs. So, according to Ferguson, an isoquant is a curve showing all possible combinations of inputs physically capable of producing a given level of output. That is the definition given by Ferguson. And we also have an assumption for this isoquant. The assumptions are only two factors are used to produce a commodity. Here we are using only the capital and labor. And the factors of production can be divided into small parts. Then the techniques of production is constant. Always the technique of production is constant. Then the substitution between the two factors is technically possible. Then the factors of production can be used with maximum efficiency. The factors of production are land, labor, capital and production. Land, labor, capital and organization. We are going to use these factors of production in a proper manner. We are going to use the resources in a proper way. And these are the assumptions of isoquants. Children, let us learn the Isoquant schedule. There are two factors, namely capital and labor. With the help of these two factors, capital and labor, and we are going to have 5 combinations A, B, C, D and E. And in the first combination A, we have 2 labor and 30 units of capital, and the output will be 400 meters of cloth. And the B combination also 4 units of labor and 22 capital, and we have 400 meters of cloth. C combination 6 units of labor and 16 units of capital, we have 400 meters of cloth. D combination 8 units of labor and 12 out capital, and we have 400 meters of cloth. And the E combination 10 units of labor and 10 units of capital, we have the same level of output, that is 400. In all these 5 combinations, different 5 combinations, we are going to produce the same level of output, and that is the meaning of isoquant. With the help of this isoquant schedule, we will draw the isoquant curve. When we join all these different combinations, we get the isoquant curve. That is, by labor will be measured in x-axis and the capital will be measured in y-axis, and when we join all these 5 combinations, we get the isoquant curve, and the IQ will be, that is the output will be only 400 meter of cloth. This is known as isoquant curve. So, or in other words, we can say an equal product curve represents all those combinations of two input which are capable of producing the same level of output. Even though we use different level of input, but we are able to produce the same level of output, and that is known as isoquant curve. The next concept will be Isoquant Map. An isoquant map has different isoquant curves representing the different combination of factors of production yielding the different levels of output. We have in this Isoquant map, we have IQ1, IQ2, IQ3 and IQ4. It shows different levels of output, that is 100 units, 200 units, 300 units and 400 units. And this is called as Isoquant map. Or in other words, we can say Isoquant map is a family of isoquants. Or in short, we can say if more than one isoquant is drawn in a diagram, it is called as Isoquant map. Children, let us learn the properties of Isoquant curve. The first property will be the Isoquant curve as negative slope. It means it slopes downward from left to right, indicating that the factors are substitutable. If you are going to use another factor more, then only it will give the same level of output. If you are going to use the capital more and the labor less, then only it will produce the same level of output. So the first property is Isoquant curve as negative slope. Second property is convex to the origin. That means these factors of production are substitutable to each other. That is, when we are going to substitute capital and decrease the labor, then it is convex to the origin, or the capital substituted per unit of labor goes on decreasing when the isoquant is convex to the origin. The third property will be non-intersection of isoquant curves. It means point A lie on the isoquant IQ1 and IQ2, but the point C shows a higher output and the point B shows a lower level of output. This is illogical. So the third property is non-intersection of isoquant curves. The fourth property will be an upper isoquant curve as a higher level of output. It means if a higher IQ shows higher output, then the lower IQ shows lower output. For upper isoquant curve, we use more factors than the lower isoquant curve. And the next property will be isoquant curve does not touch either x-axis or y-axis. No isoquant curve touches the x-axis or y-axis because in IQ1 only capital is used, in the IQ2 only labor is used. So these are the properties of isoquant curve. The isoquant curve has negative slope. It is convex to the origin, non-intersection of isoquant curves, and upper isoquant curve represents a higher level of output. And the last property will be isoquant curve does not touch either x-axis or y-axis. Children, the next concept will be the iso cost line. So the iso cost line is an important component in analyzing the producer's behavior. It is nothing but like a budget line. As we have already learned about this budget line, the ISO cost line is also the same. That is, according to the budget amount, they are going to do the estimate the cost, and that is known as ISO cost line. And here also they are going to use only the two outputs, or so that we can say that an ISO cost line represents different combinations of inputs which shows the same amount of cost. And that is why it is also called as ISO price line or ISO income line or ISO expenditure line or total outlay curve. Children, the next one will be the ISO cost schedule or the ISO cost. Suppose the producer has a total budget of rupees 120 and for producing a level of output, he has to spend this amount on two inputs, say capital and labor. So the price of factor is rupees 30 and the labor is 10. ISO cost curve can be drawn by using the following hypothetical table. So there are 5 combinations of capital and labor A, B, C, D and E, and the combination A represents 4 units of capital and 0 units of labor, and this combination cost 120. Similarly, the other combinations B, C, D and E cost the same amount of rupees 120. This is known as ISO cost line. So, symbolically we can say that 4 units of capital and 0 units of labor Also, it leads to rupees 120, 3 units of capital and 3 units of labor, rupees 120, and 2 units of capital and 6 units of labor, rupees 120, and 1 unit of capital and 9 units of labor, rupees 120, and 0 unit of capital and 12 units of labor, also 120. Thus, all the combinations A, B, C, D, and E cost the same total expenditure. From this, we can understand that the cost to be incurred on capital and labor are represented by the triangle OAE. The line AE is called as the ISO cost line. Children, already we know the concept produces equilibrium or the meaning of equilibrium, at which point the producer is going to obtain maximum profit, and that is known as equilibrium. So here the producer manufactures a given amount of output with the least cost combination of factors. That is, according to the given amount, according to the budget amount, is going to use the two factors and also produce the product at a less cost. At which point he is going to produce, and that is called as the equilibrium. So, and that is the meaning of producer's equilibrium. For this, we have two conditions. First one, the ISO cost line must be tangent to the Isoquant curve. It means the ISO cost line is nothing but the budget line. Or according to that means budget line represents the within the given amount they have to produce the product. So the ISO cost line must be tangent to the Isoquant curve. It should touch the Isoquant curve. That is the first condition. Second condition will be at the point of tangency, the Isoquant curve must be convex to the origin. This is the second point. Now, so profit of the firm is maximized at point E. Always the profit is maximized at the point E. At the point of equilibrium, the slope of the ISO cost line is equal to the slope of the ISO product curve. It means it touches the ISO cost line, the budget line touches the ISO product curve. At that point is called as the equilibrium point. At point E, so that the firm employs OM units of labor and ON units of capital. So here also they are going to use only the two inputs, capital and labor. So it obtains least cost combination to produce the level of output denoted by the Isoquant IQ. That is, to produce this 500 units, the firm is going to use the OM units of labor and ON units of capital, or they are going to use the less cost with the less amount according to the budget, and they produce the product, and that point is called as the equilibrium point, and that is the point E. The point R and S are on the higher Isoquant curve. It means it gives the higher expenditure, and that is not suitable for the firm. So this is known as producer's equilibrium. Hello children, how are you all? We have given the Cobb-Douglas production function. I am Charles Cobb and he is Paul Douglas. We have given the production function, and the production function will be Q is equal to A L to the power alpha K to the power beta, where Q is output, A is positive constant, K is capital, L is labor, and alpha and beta are positive fraction. Please go through this lesson, children, and have a nice day. Bye.